Greetings everyone. Today we are going to see is hidden Markov models. A problem on hidden Markov models. Hidden Markov models is one which determines the hidden state sequence given the observed sequence. For example, hidden Markov models has three different problems to this one. They are evaluation problem, scoring problem that is solved using forward algorithm and decoding problem that is solved using Viterbi algorithm and learning problem which is solved using Baum-Welch re-estimation procedures or the expectation maximization algorithm. So now we are going to see a problem on hidden Markov models now. Uh, so here, given the observation sequence, that is, the person takes an ice creams. Depending upon the intake of the ice creams he takes, uh, weather is determined to be hot or cold. So the hidden state sequences are hot or cold, and the ice creams it takes in the observed sequence. For example, these are the Bayesian network. The given Bayesian network is given as such: hot and cold, and one ice cream, two ice creams, and three ice creams. For example, so we have got so so initial probability of being hot is 0.8 and initial probability of prior probability of being cold is 0.2. So prior probabilities are of hot and cold are 0.8 and 0.2. And transition probability is hot given hot is 0.7 and cold given hot is 0.3 and hot given cold is 0.4, cold given cold is zero point 0.6. And one ice cream given hot is zero point 0.2, one ice cream given cold is zero point 0.5 and two ice creams given hot is zero point 0.4 and two ice creams given hot is cold is zero point 0.4, hot is zero point 0.4 and three ice creams given hot is zero point 0.4, three ice creams given cold is zero point 0.1. So this is the emission probability and this is the transition probability. These are the transition probabilities are from hot and you have got and you have got the emission probabilities also. So now we can see an example. So how to solve this? For example, they have given the observation sequence as observation sequences 1, 3 and 1. 1, 3 and 1. One ice creams or three ice creams or one ice creams. For these ice creams, for this we have got for this we have got for this we have got to compute the hidden state sequence that is hot, cold, or cold. To determine the hidden state sequence hot or cold. So here we have got two hidden state sequences and three observed sequences. So it will be about you have to change you have to make it this one. You can have a combination of hot or cold like this. First we can have a combination of hot for all the 3 days. So for the first day it takes one ice cream, it will be hot, and 3 days it is hot, and you have to find the probability of being hot for 3 days. Having taken one ice cream, three ice creams, or one ice cream for each days. So you have to find for all the combinations H. So it will be like this. You have to take eight combinations. Mm, right. Then you've got 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. So there are about eight combinations, and for HHH, HHC, HCH, HCC, CHH, CHC, CCH, CCC. So what's it? H represents hot, and this C represents cold. So now, what you will get? Wait, just come there. Yeah, this. So we got this. These are the things. So we have got the initial probability to be probability of odd to be zero point 0.8 and probability of cold to be zero point 0.2. Now, having done this, so we've got the combinations now. We've got the combinations. What are the combinations? H, and so for this, uh, for being odd, so we have to build the given sequences. One, what's the given sequence? You can see the sequence 1 3 1. So you can see the 1 3 1 is the sequence, given sequence. So now we have to find for the 1 3 1 sequence. 1 3 1, and you have to find for H. This is what you have to find. So how will you find this? 131, right? Right, so we have to find, you have to find 131 and HH. So how will you find this now? So first of all, you have to go for the emission probability. Emission probability, the probability of being one given H into probability of 3 given H into probability of 1 given H. Having given this one, having done this emission probability, then you have to go for transition probability. First, you have to go the probability of H. So probability of H is this one, this one. So this is the prior probability. This is going to be prior probability, and next one is probability of H given H and probability of H given H. So this is what you have to do. So H given H, H given H. So this is what the probability is, and you have to substitute the values, and you find the values for the HHs for this one, first one. The next one, like this, you have to continue for all the 8 values. The second one is HHC. Yeah. So you have to find probability of 1, 3, 1, H, H, C. So this is what will be this probability of 1 given H. That's the emission probability. 1 given H into probability of 3 given H, probability of 1 given C, 1 given C into probability of H into probability of H given H into probability of C given H. So you have to be careful now. H given H, C given H. So that should be the case. And now in the third case, what will be the third case? So what will be the third case? Third case, probability of 1, 3, 1, 1, 3, 1, comma, H 0, 1, 0, 0, 0, 1, 0, 1, 0, 0, 1, 0, 1, 0, 0, 0, 0, 1. HCH. So what is it again we have to give? Probability of 1 given H into probability of 3 given C into probability of 1 given H into probability of H. So this is the transition probability. Probability of that's the prior probability H and C given H into probability of H given C. This is the second one, and the third one. You have to go for the third one. You've gone for third one. You've gone for third one. 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. So like this you have to go. What is 1, 3, 1, comma H 0, 1. So it's easy. This will be probability of 1 given H into probability of 3 given C into probability of 1 given C. So this is the emission probability, and we have got the transition probability. Transition probability is 1 probability of H pH and probability of C given H into probability of C given C. Now we go for fifth probability. This probability of 1, 3, 1, comma C 1, 0, 1, C 0, 1, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0. Right. This. So here we go for this probability of 1 given C into probability of 3 given H into probability of 1 given H. We got this, and now probability of 1 given C, 3 given H, and 1 given H. That's the emission probability, and we've got probability of C, the probability of H given C, probability of H given H. So this will be the answers, and you have to calculate for all the probabilities, and you have to find the maximum of the one, maximum one. So next one, what is it? It's just C, H, C. So probability of 1, 3, 1. So we can do for different sequences, and this will be the procedure. Different observation sequences we can do, and this will be the procedures. So 1, 0, 0, 1, 0, 1. It will be probability of 1 given C into probability of 3 given H into probability of 1 given C into probability of C, should be probability of C into probability of H given C into probability of C given H. So you got 6th then and 7th one. So 7th law in the this one you have got 7, 1, 3, 1, comma C 1, 0, 1, 1, 1, 0. So 1, 1, 0 should be CCH. It will be probability of 1 given C into probability of 3 given C into probability of one given H into probability of C, probability of C given C to probability of H given C. So again we got another one, E to lost final one, we lost in final one. Right. There's one final one. What is this? That's going to be probability of 1, 3, 1. One ice cream, three ice creams, one ice cream, all things being gold. Probability of one given C, this is transition probability. Emission probability, this is the emission probability. One given C and three given C into one given C is the emission probability. We got to have a transition probability. What's the transition probability? Which will be probability of C being cold and probability of C given C into probability of C given C. So you need to substitute the values for all those things and you have to find the values. So how will you find some? So just do the calculation. We just do the calculation now. So first for the first one, one given H. What will be the one given H? So we have to do the transition and emission probability. As I have told you previously, we have found already we have been given the transition and emission probabilities. So what is it? One given H is zero point 0.2. Is one given H is zero point 0.2. So we shall do this split viewer. So we'll keep this. Uh, what is it? How to do split view? Right? Stop. So what is it? We shall note the emission and transition probabilities from this table. So one given H is 0.2. H part of H is 0.8. Part of H is 0.8. We shall do this right way. So part of H is 0.8. Part of H is 0.8, and we have to put 0.8 for everything. We know this. It's a 0.8. It's a prior probability. It's a prior probability, and it's 0.8. Part of C is 0.2. So C is 0.2. C is 0.2. Let's go this. So C is 0.2. Wait, the next. So now we have to find for one given C, one given H. One given H is 0.2. One given H is 0.2. So we'll do this. One given H is 0.2. One given H is 0.2. Right? This is 0.2. Right? We got this. We have to substitute this. And what about one given C? One given three. One given H and is 0.2, and three given C is 0.1. Given C is 0.1. Three given H is, so we have to do this. We shall substitute the values. We shall be able to find out. 3 given H, what 3 given H is 0.4. 3 given H is 0.4, right? Find it here, right? 3 given H is 0.4. 0.2 into 0.4. One given C is 0.5. And C is 0.5, right? 1.5. One given C is 0.5. And H given H, we call this H given H. H given H is 0.1. It's a transition. We have to see transition only 0.7. 0.7. 0.7. H given H is 0.7. And C given H, so we got to give 3 given H is 0.4. 1 given H, you have to see about 1 given H is right? For this first one. First one you have to find 1 given H. 1 given H is 0.2. 0.2. 0.2. And H given H is 0.7. Which is 0.7. Which is 0.7. Now C given H, you have to find the C given H is 0.3. C given H. Cold given hot is 0.3. C given H is 0.3. C given H is 0.3. Right? C given H is 0.3. We got the values and so first you will compute this value. So what you'll do, what's the value for this? 0.2 into 0.4 is 0.08. What is the rate? So it will be uh, 0.08. We have to calculate, right? So what you will calculate? How many? Listen, do calculations. I haven't done the calculations, so we'll do this. Please wait. Should do the calculations. So point two into zero point 0.4 into zero point 0.2 into zero point 0.8 into zero point 0.7 into into zero point 0.7. So 0.006272. So you get as 0.006272. Right? This is the answer for this one. And now what is this for you get for the second one? Should do this. So zero point 0.2. So we get the answers, right? So we have to find the maximum of this 0.006272. Now zero point 0.2 into sorry, zero point 0.2 into zero point 0.4 into zero point 0.5 into zero point 0.8 into zero point 0.7 into zero point 0.3. 0.00672. 0.00672. Right? This is what? Uh, zero point 0.2 into zero point 0.4 to zero point 0.5 to zero point 0.8 to zero point 0.7 to zero point 0.3. Right? Next, what do you do? So 3 given C. Now you will find for 3 given C and 1 given H. 1 given H is we have already found to be 0.2. So we'll do this. Do this. 1 given H is 0.2, 1 H is 0.2, and 3 given C you have to find, right? 3 given C is 0.1. 3 given C is 0.1. No, it's 0.2, 1. And H given C? What's the H given C? H given C also will find. Odd given cold is 0.4. Odd given cold is 0.4. So we will find 0.2, 0.2 into zero point 0.1 into zero point 0.2 into zero point 0.8 into zero point 0.3 into zero point 0.4. So it's 0.000384. It's going to be 0.000384. Right. So it's the next one. Most 3 given C is 0.1. 1 given C already done, right? 1 given C is 0.5 and H is 0.8 and C given H. C given H is 0.3 and C given C. Then you anyway written a cold given cold. So you can fit cold given cold. What's cold given cold? Is 0.6. 0.6. So calculating this, get zero point 0.2 into zero point 0.1 into zero point 0.5 into zero point 0.8 into zero point 0.3 into 0.6. 0.00144. It will be 0.00144. Next we go for CHH. What is CHH? One given C, what's one given C is 0.5, and 3 given H. 3 given H. We've already done this, right? 3 given H. 0.4. It's 0.4, right? And 1 given H is zero point 0.2. You know, C is zero point 0.2 and H given C. H given C. We got that. H given C is zero point 0.4. And H given H is H given H. We got is 0.7. So calculating this, 0.5 into 0.4 into zero point 0.2 into zero point 0.2 into zero point 0.4 into 0.7. 0.00224. The 224. So we've got the values. Sixth one we'll do. Now 1 given C. What's 1 given C? Is 0.5. 3 given H is 0.4. 1 given C is what's only 0.5. And C is 0.2. And now H given C is 0.4. C given H. C given H is zero point 0.3. Calculating this, what will be getting? So again, zero point 0.5 into zero point 0.4 into zero point 0.5 into zero point 0.2 into zero point 0.4 into zero point 0.3. This is 0.0024. So next we'll go for this. 1 given C. 1 given C is again 0.5. 3 given C. What's 3 given C? 3 given C we've already done, right? We have got 3 given C. Is 0.1. It's 0.1 now. 0.1, 0.1, should be 0.1. 0.1. It's 0.1. 1 given H is 0.2. 1 given H is 0.2. 0.2 and now 3 given C. What is going to be C given C? Is going to be written on this, right? C given C already done already. We got this 0.6. 0.6 and H given C is 0.4. So substituting values we get 0.5 into 0.1 into 0.2 into 0.2 into 0.6 into 0.4, which is 0.0048. So 1, 3, 1. Last one we are going. 1 given C is 0.5. 3 given C is 0.1. 1 given C. Again, 1 given C. What's 1 given C is 0.5 again. It's 2.2. No, 0.5 into 0.1 into 0.2 into 0.2. 0.6. Right, that's 3. C given C is 0.6 and this is total 0.6. 1 given C is 0.5. 1 given C is 0.5. So we get this. So 0.5 into zero point 0.1 into zero point 0.5 into zero point 0.2 into zero point 0.6 into zero point 0.6, 0.0018. So we got the values. Having got the values having got these values, which is maximum among this? 0.0018. This one won't be there. 24 is greater than 0.0018. So it's having higher probability. But this is 20, so it also doesn't have. So wait a minute. What will be the higher probability? So to find the maximum of this, so to find the maximum of this, .00024 is also not there. 0.00144, this is also not there. 0.00672. So it should be HHC. This should be the this should be the value. So what should be the values? So your optimal sequence should be 0.00627, which is on this point. So this should be the this one HHC. That should be the answer. Your answer for 131 should be HHC. It should not be. It should be HHC, right? One ice cream, three ice cream, and one ice cream for the most probable sequence. So we have solved a problem. Most probable sequence for sequence. So it should be maximum of that. Maximum sequence of one ice cream for the observed sequence. Observed most probable sequence, hidden state sequence. Most probably hidden state sequence for one ice creams, three ice cream, and one ice cream is ice cream you got is hot, cold, hot, cold. Right? Sorry. It should be hot, cold. So hot, cold. HHC, right? It should be HHC, hot, cold. So this should be the answer. So we got HHC as a hidden state sequence. Most probably hidden state sequence. Most probably hidden state sequence as we got as HHC, hot, cold. That's the answer. So thank you very much. And